essentially this project was about collecting all of the historic data. So it's everything from the 1960s through to the current data sets that we get now, through fertiliser companies, as I say, and predominantly through a lot of department data. So there's a lot for South Australia that's historic, and most of the data nationally is quite old. So it's older than 1995 in most cases. There is some new data that's in the database, and really what this presentation will be about is showing you the tool that we use to access the data, and that will start to become available from April this year. So we're going to start running some training workshops to give people access to the database. The idea is, from this data, is to start using it as a single national set of data that can be used to underpin the decision support systems. It's not about fertiliser recommendations, it is about soil test interpretation. Really, the contributors to the project, a number of those companies have recommendation tools. This is about providing a consistent source of data to help underpin that, which those decision support systems are tested against. Okay, so it gives us something against which we can look at the data that's used in decision support systems, and is it consistent? This is one large data set to underpin that nationally. As I said, it's about data from the 1960s onwards. It's all about the fertiliser response data. So it's about N, P, K and S only. It's not about micronutrients. We've got all the data that we can into the database at this point. There are some 100 trials that we're still trying to get into the database nationally, but we're somewhere around about 5,000 trials. Previously, there hasn't been a repository for these sort of data. And so some of the challenges we're now finding with the data, how we interpret it, how we understand it, how we use it, we haven't come across before. So there's a big case for this to be an ongoing project, and indeed GRDC are looking to fund this into the future to build data that they're looking at through future projects and include that in the database. Essentially, it's about providing independent and consistent soil test calibrations for the industry. That's the message out of this. How we make it available is through a tool called the Interrogator, which is a tool that's a search engine essentially. You type in a series of query questions, and that allows you to pull out a set of data and look at a calibration response for that data. It's an agreed approach. So what we've done is we've looked at it, we've pulled together a statistical method to do this, and got that peer reviewed by the team. So the team includes a lot of people who are retired, a lot of scientists who've been around for a long time looking at these data, a lot of the guys who've actually collected the data in the past, contributing to the approach for how we look at it, how we bring it together, how we analyse it. Then what we're doing is putting together a series of technical and training publications so that we can make it accessible to people, and indeed so that people who don't necessarily access the tool can gain an understanding for what that tool is and what the data tells us. It's about registration. So what we're looking to do is get people registered to use it, not because we don't want people to use it, but because we want people to have a certain level of knowledge before they do. Because as I say, it's not about recommendations, it's about soil test interpretation. It's aimed at agronomists, it's aimed at the advisors in this room, it's aimed at fertiliser companies, and it's aimed at researchers. It's about providing a standard method for soil test interpretation based on the historic data and based on statistically valid results that have been drawn together. As I say, about 5,000 trials. There's 5,460 trials in here. A lot of trials haven't been included in here. They haven't been included because they don't have a soil test. They might not have had a valid replication design put together for the trial. They might not have had a maximum yield defined in the trial, so they might not have reached a maximum yield, and therefore we can't say that the phosphorus, for example, was non-limiting. Really, this is then going to underpin the FertCare accredited advisor system of making recommendations. It is going to be looked at as being the best available data set. It's not going to be the only data set that's available, but it will be the one against which everything is compared. And that's the statement that's been made by the Fertiliser Industry Federation. It does not provide the recommendation. It is about a single stage interpretation as part of a recommendation. We need risk, we need interactions, knowledge of the region, we need target yields to better understand that and to put that into context for a recommendation. In terms of the data that's available, most of it is for wheat. There's no surprise there. Most of the recommendations have been then based around those trials and understanding how other crops might fit into the rotation. For South Australia, there's a substantial body of data in barley for nitrogen, and then some data for phosphorus. There's some canola data. Really, once we move away from those three crops, and indeed for field peas in phosphorus, there is not a lot of other data for the database for South Australia. Indeed, nationally, we move away from lupins, canola, barley and wheat, and there's a lot of gaps in what we know and the trials that have been conducted. GRDC are looking to put some money into this over the next 5 years through an ongoing investment in nutrition research, and some of that will seek to fill these gaps. Some of that will start to answer the questions about this being historic data and how does that compare to more recent understanding of nutrient response. We have some understanding of that from the database. We have some comparison of no-till systems against conventional systems, but it is quite a small amount of data at this point in time. Remembering that investment has been historic, not more recent in trial research. In terms of the soil test methods that have been used, and the question's already been raised about DGT. At this stage, I've only put up 4 of the phosphorus methods here, but most of the data, if not all of the data, there's barely a handful of trials that don't have a Colwell P test associated with them. Most of the data that's been used in the past has looked at Colwell P. We have an increasing body of DGT data which Sean is putting together. We have some Olsen P data. And I've also put up here the Malick P3, and I put that up because that is something that has been mentioned at times about a possible test, and there hasn't historically been any work in this area, but those 181 trials were samples that we then re-ran with Malick number 3 to look at this question about is it valid or not. So we've got these types of data in the system. We've got a lot of nitrate N data. One of the questions with the information that's kept in the database is that it depends on which soil test depth people used when they did a trial. And so one of the challenges with nitrogen data is that they could have used any depth. They could have used 0 to 10 for their trial, they could have used 0 to 40 for their trial. As we get along in the presentation, you'll see that we're going to recommend to people that if they're doing a trial, we want at least the 0 to 60 for trials in nitrogen across Australia. If people do other depths, that's okay, but we, for the database, need to build a body of data looking at 0 to 60 for all states, is what we're looking for. What I'm going to do is run through a series of examples with you from the Interrogator. If you log into our web page at the moment, what you'll see is this page. You won't be able to log in, you'll have to supply a password and a username, but what I want to do is take you through what is in here, in essence. And the dots, the grey dots you see on the side here around Australia are all the trials that are in there. They are all the trial sites that exist. If I go to the first page of the interrogation tool, it allows us to then select a nutrient, a region or a state, and then select our crop types and our soil types. And so what I'm doing in the first example is just running you through the nitrogen example, and I'll indeed run you through the other examples that are in the paper. So what I've selected is nitrogen and cereal wheat. Then I've come to the second page. I flick through by touching on this button down here which says select the trials that satisfy the selection criteria above. Takes me through to this page, which allows me to refine that search. What I then do is decide which soil test method I'm looking at, which soil test depth I'm looking at, and then I can start to refine that. And so what we'll do in the first instance is look at nitrate N and the 0 to 60 depth. I just want to refer you to this point here, and Doug and I have been discussing this earlier, but the point about looking at relative yield or yield increase, 2 ways of looking at the response of trials to fertiliser. Indeed, in this, when we fit a calibration curve, we do it with relative yield. We always need to have a plot or a treatment that has had no fertiliser applied, and we need to have the maximum yield from that trial where the curve is flattened off. Looking at the nitrate N and 0 to 60 for all of the soils in South Australia, all of the rainfalls, this is what we can pull together. And that indeed gives us our figures down here, about 80, 90 and 95% of relative yield, and a critical value associated with that. I say value because next to that we have what we're taking to be our critical range. Okay, so that's the 95% confidence interval that the curve is in the right spot on that data. Okay? What we can also do is look at one of the points on there. We have an outlier. Why has that outlier been included in the database, or why wasn't it excluded? So we can look at the trial data that goes with that. So we've stored all of that trial data for the particular, for each trial. Everything that we've got that exists is in the database where trials have been put into the database. Okay? And this is one of Dennis Elliott's trials. This has a particularly large amount of data associated with it. There are a lot of trials in the database that have a small amount of data associated with it simply because it wasn't reported or it wasn't collected. We had a fair degree of scatter within that curve, so what I'm going to do now is scroll down the page and look at some of the filter options that we have in the interrogator so that we can pull that data apart and start to look at a curve for that. I've selected here growing season rainfall, and I'm going to select all the trials that have a growing season rainfall less than 300 millimetres. And then I put together this curve here. So I've selected on the curve option. I'll just take you back a second and just point to this here. What we can do in the interrogator here is plot that, and those options are down below the soil test. We can also tabulate the data, all of the trials associated with the curve that we're about to plot. So we can see here that there's a reasonably good fit with the 0 to 60 data for nitrate N, where we've got less than 300 mils of rainfall in growing season. What happens if we look at the greater than 300 mil growing season rainfall? That's where a lot of our scatter is. So our trials are much more dependent on other factors other than the nitrogen that's in the system there. Let's look at the phosphorus data at barley. I've selected the three barleys in here, the general barley that's been entered because we haven't known whether it's feed or malting, the feed barley, the malting barley. I've then selected all soil types, and this highlights this question about calcareosols and how we look at those differently and what soil tests might be different. I flick through to the next page of the interrogator, and I've selected Colwell P. I'm not going to show you DGT because there wasn't the time, but I want to look at Colwell P for 0 to 10. And that's including all soil types. What happens if we then take out the calcareosols, and you can see down here that I've excluded those calcareosols and included all other soil types where trials have been done in South Australia. I've gone back to the same soil test depth and Colwell P. And here is that data again without the calcareosols, without the trials that have been done on calcareosols. However, there's still a degree of scatter within that curve, and we can see some difference between some data on this side and some data to the left of that, some trials. So what I want to do is then look at a difference in maximum yield and see if there's some difference in that data that depends on the maximum yield of the crop, of the trial that was run. So what I've selected in my filter option is trials that have more than 2.5 tonnes but less than 4 tonnes to develop a calibration curve. And indeed, here is the calibration curve then that is drawn from that set of data. If I look at maximum yield more than 4 tonnes, I can put that up again. Just note there that the 90% relative yield is 19 for that series of data, but for this it's somewhat lower at 14. Now they're small differences, but we can start to pull these differences out from the data. I then want to compare the calcareosols. I'm going to take all of the calcareosols without filtering them for Colwell P and 0 to 10 centimetre soil sampling depth. It's a pretty rugged curve that we can see for that data. However, if we start to put in a maximum yield, we can start to look at that curve that's coming from the trials that we have in the database. So this is really a mechanism to try and understand the data, try and pull it apart based on what's in there and try to better understand what we've got. I haven't gone into looking at the differences between conventional trials that have been done under a conventional system and trials that have been done under a no-till system. There are very few trials nationally for that have been included. They simply don't exist, and we need to get more of them in there, and we're looking to do so. This brings us to our next question. Some of you will be doing trials, will run your own trials, GRDC have asked us to put together a minimum data set for future trials. What do we need from people who are conducting trials? What do GRDC need from projects that are doing trials that we can then use, so we can use that data and put it into the database so we can compare it to the old data and answer some of these questions about farming system, about soil testing methods, building an increasing body of soil test data, comparing things like DGT and coal wool, where we have the phosphorus buffering index as well, and build that into the database so we can look at it. This will be available from the project website, which we're looking to make available from March. While we're having from late March, should I say, while we're having the training start in April, this project won't be finalised till the middle of the year, and we'll launch it sometime in the middle of the year. So it might not be available on the 1st of April, the website. If it's not, it will be available shortly thereafter. What we need is a description of treatments applied from a trial. Now, some of this doesn't seem like rocket science. It's pretty simple. It's pretty straightforward. But these are some of the holes we had when we looked at trials, so that's why we're making it clear that this is what we want. It's really difficult to develop a response calibration from data that doesn't have a balance of nutrients in the treatments. We need a statistically valid trial design. We need a nil treatment. We need a treatment that gives us maximum yield at the trial site. We need the trial yields reported if you're going to publish it in a report. And that is another one that seems quite straightforward, but it's not always done. In terms of soil testing, we need to know what the soil fertility is at the site. Yes, if it's a phosphorus trial, we want to have the phosphorus data, but what other data could help us understand the trial? We need to know Australian soil classification. We need to know what the texture is. These information all help us to understand that trial. We need to know what the sampling depth and the depth and the time of sampling is. And we need to have some recommended soil testing methods used. We'd like to have the coal wool P for phosphorus. If there's another method, let's use it. Let's use DGT as well. Let's run it. But remembering that the body of data at this stage is all about coal wool. If you're going to run coal wool, we need phosphorus buffering index. We need PBI to go with it. If you're looking at potassium, we're suggesting that a 0 to 10 soil sampling depth is appropriate, but that people should consider 0 to 60. For sulphur, we're suggesting that the same depth should be used as nitrogen. So we should look at sulphur when we look at nitrogen. In terms of getting access to this, people want to get access to it when they see it. They generally are interested in having a look and having a play. As I say, we're going to run some workshops. We're going to run some training days. They are half-day training events. They're going to be run by Back Paddock in the first instance, where we're going to train the trainers. The fertiliser companies in the project, Elders, Landmark, are involved in the project, and there has been involvement from them so that they are training people in the industry to use the Interrogator. Okay, we're looking at trainers to train people so that then they can train others to use it. We don't want to be leaving this with a limited amount of access. GRDC are looking to fund this for the next 5 years. Within that, we're looking to put this training package together into an online training tool so that you can go through the training online, so you can do that there, you don't have to go to a training workshop, and you can go through it and get access that way. It's all about understanding what the project is, what the intention of the project was. It's about understanding the data that's included and the methods that are used to analyse that data. And these seem quite trivial in some senses, but they're important to understanding how you use this information. And that's the important part, and that's why we want people to be registered to use it, so that they understand what they're doing with the data. How does the soil test calibration fit as part of a nutrient management strategy? Big important question. There's going to be 10 workshops, up to 10 workshops run across Queensland, New South Wales, Victoria, South Australia and West Australia. Get in contact with myself or get in contact with Chris Dowling. We can get you into a Train the Trainer if you would like to be as part of that. Alternatively, let us know if you're interested in getting access into the future, because we will find a way to get you access to it through going through one of these training courses, either before as part of the Train the Trainer or afterwards as part of some other workshops. We're really looking at this stage to get people to use it and understand how to use it who can train others, because we need to push it down, and there are a lot of advisors across Australia who we would like to have access to this. As I say, there's a fairly large contribution to this project. A lot of people have put in a lot of time to this, a lot of retired researchers have put in time to this and given data that they've stored for many years. Without many of the retired people who've kept this data, a lot of it wouldn't exist anymore. The number of times that we've gone to someone's filing cabinet at home simply because it doesn't exist in some other storage facility anymore to find the data. This was a really important contribution from all the parties in this project. Otherwise, we wouldn't have the data now that we have, and we wouldn't be able to look back and then have the ability to look forward over the next 5 years of investment in this area. So look, get in contact. We'd like you to use the database. We'd like you to be able to access the Interrogator. We'd like you to understand it and to use it for what you do in your work. Thanks very much.
Within season rainfall,
Yep.
you're going to put down the monthly, because obviously you get 300 million of rainfall during the whole growing season. You still might have a couple of dry months in between. And I thought subsoils and hostile subsoils really need to be noted.
Yep. Look, if we've got the subsoil constraints in there, so if there's been soil test data for that, for the depth, we've got it. In terms of growing season rainfall, it's only in there for sowing to harvest. We didn't enter it. And often it could exist as monthly, or it might just exist as one value for the year. There's a lot of trials also that simply don't have that information. So when people start to look at this database, what we encourage them to do is to look at the big data set first and then to drill down. And the reason we do that is because a lot of the metadata, the additional information that helps us understand the trial, doesn't exist for a lot of historic trials.
So I'm really concerned about just looking at soil test data and not bringing physiology.
Yep.
I mean, your phosphorus calibration curves there are done on a particular time of sowing.
Yes.
There is not that breadth of sowing time. We can change the response curve easily by sowing earlier or later. And I think it's just too dry.
One of the things that one of the chaps from Wagga and I would like to do at this is look at the difference in sowing time with the data we've got, because there is a variation in sowing time. We've got the varieties where we can, so we want to try and drill down into that. We don't necessarily do that through the Interrogator, but we want to pull out the data that's in the database and try and understand that better, so answer some of those questions where we can, where it exists.